Hello there, Algebra students. This is Mr. Kashi speaking. We're going to go through our lesson here on 9.6, which is factoring trinomials with an a that is greater than 1. So just kind of how we did last chapter, we're going to kind of describe this as the opposite of multiplying binomials. So we're gonna multiply a binomial and show you how it goes the opposite direction. So we'll use the FOIL method for this one. So we're going to do 2x times 5x to multiply this out first, and we'd get a 10x squared. And then we'd do 2x times 3, which we would get 6x. And then we have 5 times 5x, which is a plus 25x. And then we do 5 times 3, which is 15. And then what we would do is we would combine those middle two to come up with 10x squared plus 31x plus 15. So this direction is obviously multiplying binomials, and that has been a skill that we've been practicing quite a bit lately. And now today what we're going to be doing is we're going to be going back this way, and this is what we call factoring. And this process is difficult for a couple of different reasons. First of all, we have this number out front, this 10, and this 31 is a difficult number that we actually have to split up into these two numbers. But our a term out front complicates that from time to time. So just to review what standard form is. Standard form is ax squared plus bx plus c, and these are the numbers that we're going to be using and try to find out what those are. And we'll be factoring and putting it into factored form. And today all of our a terms are going to be greater than 1. There should be an e there, eh? All right. So in this case, we have this is a method called the AC method, and it's called the AC method is because we take a and c and we multiply them together. Okay, and so we have 6n squared plus 23n plus 7, and so we take our a and we multiply our c, and that would mean 6 times 7 is 42. Okay, and then what we need to do is kind of like we did with the table and the diamond. We can still use those strategies, but now we're going to use the 42 instead. So we need factors of 42, and their sum needs to be 23. Okay, and this one's a little bit easier because they're all positive. So we could list out the factors. We got 1 and 42. Those don't add up to 23. And 2 and 21, and those do. So that's how we can find our two factors here. But there is a little bit more of a process here. So 2 and 21, we can't just split them up because of that 6 in front. And so really what we have to do is we have to take this whole expression, and we're going to split that 23n into two parts. So it's going to look like this. It's going to look like 6n squared plus 2n plus 21n plus 7. So this 2 and 21, we found those factors. That's where we're getting the 2n plus 21n. Okay, so we're splitting up that 23n into 2n plus 21n. Then what we need to do is we're actually going to be dividing these into two groups. So there's two terms on the left and two terms on the right. Okay. Then we have to factor out a common factor. So a common factor between 6 and 2 would be 2, and a common factor between n squared and n would be n. And then what we leave in the parentheses is what's left over. So we have 6 divided by 2, that would be 3. And for this n squared, one of the n's came out here, so then we leave an n inside. And then for the second term, 2n, this whole 2n got factored out here. So we still need to put a +1 inside. Okay, so because 2n divided by 2n would be 1. Same thing on the right-hand side. We got to factor out as much as we can. They don't have an n in common, but they do have a 7. So 21 goes into 7 3 times. So we can factor out a 7, and we get 3n. And then we factored out that whole 7, so we just have to put a +1 behind it. Now, the one thing that you have to make sure happened is that these two expressions are the same. That is very important. If that didn't happen, we did something wrong along the way. And then what we just have to write this in factored form. So one of the factors is 2n plus 7. Those are the terms that we factored out. And then the other one is just the one that repeats. So we have 3n plus 1. So this would be your expression written in factored form. And this is obviously the first step in solving quadratic equations. So if you could, please take some time, and I would like you to solve these two on your own. And when you're done with that, please let me take a look at that, and then I will instruct you to move on to the next video.